Hello guys, in this video I'm going to tell you so many interesting facts about squares. In mathematics, squares take a very important place and they help in doing so many interesting math calculations. So let's get going. Let us learn what are squares. A square of a number is the product of the number with itself. It can be also understood as addition of itself as many times. Square of 2 is 2 into 2 equal to 4. 2 is added to itself 2 times. 7 square is equal to 7 into 7 which is 49. 7 is added to itself 7 times. We denote a square of a number by raising the number to 2. Like 2 square is written as 2 and we write a 2 in a smaller font on the upper side. And square of 7 will be written as 7 raised to 2. Thus 2 is written in a smaller font. Squares of single digit numbers. It is like a pattern. 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16 and so on. You are seeing that I have highlighted the unit digit of all these numbers. They form a unique pattern. 1 square, any number ending with 1 will have the unit digit as 1. No choice. 2, any number ending in 2 will have its square ending in 4. In the case of 3, it is 9. In case of 4, it is 16. And if we see in the other way, it is the same way. Like 1 square will end in 1, 9 square will end in 1. 2 square will end in 4, 8 square will end in 4. 3 square will end in 9, 7 square will end in 9. 4 square will end in 6, 6 square will end in 6. But 5 is the most unique and it will be very different from any other number. Squares of number sequence 1 to 9 will follow the order of 1, 4, 9, 6, 5, 6, 9, 4 and 1 in the units place as shown and marked. It is true for any number sequence 11 to 19, 21 to 29, 31 to 39, 51 to 59 and so on. Squares of 11 to 19. It also has the same pattern. You can see 1, 4, 9, 6. 1, 4, 9, 6. And the 5 is left out here also. It is true for any number pattern. Same in the case of squares of 21 to 29. 1, 4, 9, 6. 1, 4, 9, 6. And the 5 is left out. Now the last digit of a square. The last digit, that is digit in the units place of the square of a number, can be easily identified if we know the squares of all single digit numbers. All single digit numbers. For example, square of 82 will have last digit as 4. As we learned, 2 square is 4. So ending will be 4. Since the unit digit of 82 is 2 and square of 2 is 4. The last digit of any square cannot be 2, 3, 7 and 8 because they are not a square of any single digit number. Therefore, a square of any number can only end with 0, 1, 4, 5, 6 and 9 only. The square of any number ending with 5 will have the last two digits as 25. Last two digits as 25. We can take any number, it will end in 25. In the 0 case, it will have last two digits as 0 only. The square of any odd number will be an odd number, and square of any even number will be an even number. Number of digits in any square. Number of digits of a square of a single digit number will be minimum 1 and cannot exceed 2. The maximum single digit number is 9 and square of 9 is 81, which is 2. Same in the double digit number case. It will be minimum of 3 and cannot exceed 4. So 99 square is 9801. Same in the 3 digit case. Square of 999 will be equal to 9,98,001, which is 999 is the highest or the greatest 3 digit number. It cannot exceed 6 digits. Number of digits of any square and digit number will be minimum 2n minus 1 and cannot exceed 2n. It is just a formula to remember. Formula to find squares. There are some formulas which we can use to find squares. A plus b the whole square is equal to a square plus b square plus 2ab. This formula we can use to find the square of number ending from 1 to 4. It is usually used to find square from 1 to 4. 72 square is equal to 70 plus 2 whole square, which will be equal to 70 square plus 2 square. We are just distributing 70 and 2 plus 2ab, which is 2 into 70 into 2, which is 4900 plus 4 plus 280, which will give us 5184. Now the second formula is a minus b the whole square will be equal to a square plus b square minus 2b. The difference is if we add here, we add here also, and we subtract here, we subtract here also. This formula is usually used to calculate the square of number ending from 6 to 9. Here we use it from 1 to 4. Here we use it for 6 to 9. So if we take a number ending from 6 to 9 like 78, 80 minus 2 whole square. Now we will distribute it 80 square plus 2 square minus 2 into 80 into 2, which will give us 6400 plus 4 minus 320, which will give us 6084. Now there is one more formula. If you want to subtract two squares, a square minus b square will give, which will be equal to a plus b bracket into a minus b. We have to multiply these, and if we simplify the equation, we can find a square will be equal to a plus b into a minus b plus b. The b has shifted to the other side of the equation. This formula can be used to calculate square of any number. It can end from 1 to 4, 6 to 9 or any digit. Now if we take a number like 52. 52 plus 2, 52 minus 2. Why we are doing is that multiplication with 50 is easy. So 52 minus 2 is 50. 52 plus 2 is 54. And if we multiply this, we will get 2700. 2 square is 4. We all know that. We just add it. We simply get 2704, which is the square of 52. Same in the case of square of 98. 98 plus 2 is 100. Multiplication with 100 is very easy. And 98 minus 2 is 96. And if we multiply 96 with 100 and add 4 to it, which is 2 square, we get 9604. Squares of any number ending with 5. There's a very special trick by which you can find the square of any number ending with 5. Before we start the trick, let's take a number as 45 as example. There is only 2 steps. Yeah, right. There are only 2 steps for finding the square of a number ending with 5. So first we multiply the units place, tens place with its next number. So for that we take the number 4 in this case, multiply it with its next number. 4 plus 1 is 5. So 5. 4 into 5 is equal to 20. Now the second step is attach 25 to the product. You get in step 1. So we got the product as 20. Now to just attach 25 to 20. So we get the answer as 2025. We attach 20 to 25. We get 2025. Squares of numbers ending with 0. Number of zeros in a square of a number ending with 0 will always have even number of zeros. It cannot be odd number of zeros. The square of 40 is 1600. It has 2 zeros. Square of 620 is 3,84,400. It also has only 2 zeros. And if we take an example of 400, its square will be equal to 160000. So it also has only 4 zeros. It cannot be any odd number. It can never have odd number of zeros. Now there is a very interesting method called the diagonal method of finding squares. First, we take a number as 326 and we make a small 3 by 3 grid. We draw diagonal lines on this grid and then we start multiplying. So 3 times 3 is 9. We put the tens digit here and the units digit here. Now 3 into 2 6, 3 into 6 18, 3 into 2 6, 2 into 2 4, now 2 into 6 12, and then you have to fill the grid with the multiplications of number from each coordinate. Now there are diagonals 1, 2, 3, 4 and 5 diagonals. So now we add the numbers between the diagonals. Now for adding first diagonal we get 6, so we write the 6. In the second diagonal we get the sum as 2 plus 3 plus 2 7. The next diagonal we get 22. We write the units place and carry forward the 2 to the next diagonal. So now while adding the next diagonal we add 1 plus 6 plus 6 plus 1 plus 2. We get 16. We write 6 here and carry forward the next digit. Now 1 plus 9 we know it is 10. So we write the unit digit here and carry forward the 10th digit. And 0 plus 1 is 1 and we write 1. And as you can see, the square of 326 is 106276. Now there are more ways to find squares. Method 1. If we know the square of a number, say n, we can find the square of the next number by just adding n and n plus 1 to the square of the previous number. So if we know 11 square is 121, then 12 square will be equal to 11 square plus 11 plus 11 plus 1, which is equal to 12, and we get the square of 12 as 144. And there is another method to find squares. If n is a number and we want to find n square, then we can add n consecutive odd numbers. For example, if we take 5 square, we add the first 5 odd numbers, so which is 1, 3, 5, 7 and 9. And if we add those, we get 25. Now 10 square, we add the first 10 consecutive odd numbers, which is 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19, which gives a sum of 100. Now there is a method 3 also for finding squares. So to get square of any number, we say n, add 2n plus 1 to its previous square. To find 6 square, we use 5 square and 2 into 5 plus 1, which is 2n plus 1, which gives us 11. So we simply, to get 6 square, we add 5 square plus 2 into 5 plus 1, which is 11. We get 36, which is the square of 6. We can use it to find any square. Now let's take another small number 10. For finding 10 square, we use 9 square and 2 into 9 plus 1. So 9 square is 81. 81 plus 19 is 100. So 100 is again 10 square. And let's say 23. 23 square, we have to use 22 square. 2 into 22 plus 1, which is equal to 45. 23 square is equal to 22 square plus 45, which is 529. Now let's take 71 square. We use 70 square. 2 into 70 plus 1, which gives us 141. 70 square plus 141 gives us 5041. Interesting squares. Math is like magic. There are many special squares which may amuse you. These numbers are also called as a palindrome, which are like a mirror. So let me show you some. 12 and 21, they are like a mirror. And the squares surprising are also like a mirror. 144, 441. Same in 13 and 102. 13, 31. The squares are also mirrored. Same in 102 and 201. The squares are mirrored. There are many interesting squares like 113, 311, 1003, 3001, 2012 and 2102, and so on, and there are infinite possibilities. The digits are reversed and this is like magic. There is very interesting fact that these numbers have 0 to 3 digits only. Like 12 has 1 and 2, 13 has 1 and 3, 102 has 102, and there is no such combination which has such magic which have digits greater than 3. Difference of squares. The difference of squares of two consecutive numbers can be represented as sum of numbers. Like 8 square minus 7 square will give, the difference is that 8 plus 7. So simple, we get 15. We have to not practically subtract them. Now 28 square minus 27 square. We have to just add 28 plus 27, we get 55, and that's our answer. 150 square minus 149 squares. We just add 150 and 149, we get 299. We can verify this using a formula also. N plus 1 whole square minus n square is equal to n square minus plus 1 square plus 2n minus n square. In this formula, n square minus n square gets cancelled. So we get 2n plus 1, which is the sum of two consecutive numbers. The Pythagoras theorem, the most famous theorem which uses squares. We use squares in Pythagoras theorem. This theorem is applicable for right angle triangle. The longest side of the right angle triangle is the hypotenuse. Let us assume it as C, and other sides may be assumed as A and B. Then according to the Pythagoras theorem, A square plus B square is equal to C square. So let's take an example. Let's consider A to be 6. And then B to be 8. By using the squares in Pythagoras theorem, we get that C is equal to 6 square plus 8 square, which is equal to 6 square, 36 and 64, which is 100. And if we take the square root of 100, we get 10 centimeter, which is the length of C. The Pythagoras theorem triplets. These triplets are the numbers which tell the possibilities of length of sides of a right angle triangle. So, if n is a number greater than 1, we can, for any value of n, we can find Pythagoras triplets. This is very amazing. They are 2n, n square minus 1 and n square plus 1. Very simple. For n is equal to 3, for example, 2 into 3 is equal to 6. 3 square minus 1 is equal to 8. 3 square plus 1 is equal to 10. So the triplets are 6, 8 and 10. n is equal to 8. 2 into 8 is equal to 16. 8 square minus 1 is equal to 63. 8 square plus 1 is equal to 65. So the Pythagoras triplets are 16, 63, 65. For n is equal to 21, 2 into 21, 42. 21 square minus 1, 440. 21 square plus 1, 442. So the triplets are 21, 440 and 442. There are vedic math trick also for 2-digit numbers to find squares. Let's take a number, say 43. We make a 4 by 4 grid. Then we multiply the 10th digit and we write it in the top of the grid. In this case, it is 4. So 4 into 4, 16. And then we write 16 in the top of the table. Now we multiply 4 into 3 and multiply it by 2. And we get 24. And we have to write it in the second row. And for the third row, we take the square of the units place. So it is 3 into 3, 9. And we write 9 here. If the square of the units place is a 2-digit number, we write the tens place here. And for this square of the number, we just add them vertically and then we get the answer as 1849. So this is the square of 43. Let's take another number, say 89. So we draw the grid. Then we multiply the 10th digit, we get 64. Then we take twice the product of the 2 digits, which is 144. Square of the unit digit, which is 81. Then place the following digit on the grid and just add. We get 7921, which is the square of 89. Let's take another example. We can take the number 77. Draw the grid. Take the square of the 10th place. Twice the product of the numbers, 98. Then the square of the units place. Then we add it. Then we get 5929 at the square of 77. Thank you guys for watching.